Hi everyone, in this video we're going to take a look at equations of a line, parametric equations of a line, and also find the distance from the origin to this line. Okay, so first I am going to write the equations of the line, but I am going to write them in the form number plus number t, each one of the equations. So the first equation will be 0 plus 5t. The second equation is going to be 2 plus 1t. Right? It's the same thing as t. And then the last equation is going to be -1 minus 3t. Okay, so what is a point that these equations are based on? So the point is going to be this one. So the numbers without the t, that's the point. So let's call this point P. So the coordinates are 0 to -1. And then to find the vector that gives direction of this line, you look at the coefficients of t. So those are going to be, and of course, including the sign. So this will be +5, +1, -3. Now, be careful with notation because 0 to -1, that was a point. We need parentheses. But since v is a vector, we need angular brackets. So this would be 5, 1, -3. Okay, so let's go ahead and put that here. So this is 0 to -1. And then this is a vector. So we want vector brackets. 5, 1, -3. Now we have to find the distance from the origin. Now, by the way, origin is will denote it by O, has all three coordinates 0. So just imagine this the following picture. So imagine that you have a line and you have a point on that line. That's point P. And then the vector V, which is the direction of this line, I'm just going to draw that. And of course, I'm not drawing the actual vector, but just showing you the idea. I am going to draw this vector starting at P, because you can always translate a vector and it doesn't change as long as the length and the direction doesn't change. So imagine that this is your vector V right here. And then the origin will be somewhere over here, not on that line. The first thing you're going to need to do is construct a parallelogram out of OP and the vector V as adjacent sides. So you're going to need to draw a parallelogram like this. So just imagine that, okay? What is the area of this parallelogram? So knowing the formula for the area of the parallelogram, it is going to be norm of the cross product of two adjacent vectors. So think of the vector PO is the adjacent sides of the parallelogram crossed with a vector V. Okay, so first let's find PO. What are the components? So because a vector PO initial point starts at 0 to -1 and ends at 0, 0, 0, we're going to subtract. So 0 minus 0, then you got 0 minus 2, and you got 0 subtract -1. So that will give me 0, -2, and +1. Okay, so now I'm going to cross that with my vector, the direction vector. Find the cross product. So let's do that. So we got I, j, k for the first row. Then vector v with 5, 1, -3. And then PO with 0, -2, +1. Okay, so what is the ith component? So remember, for the ith component, you want to cross out the first row and the first column. And what you would get is 1 subtract -2 multiplied by -3. Then we do minus j. And now we're going to cross out the row and the column with j's. So that will become 5 times 1 minus 0 times -3. And then finally, we'll get plus k. So here we want to cross out the last column and the first row. So that will become 5 times -2 subtract 1 times 0. Okay, so simplifying that, the cross product is going to become, so this is 1 subtract, because there are 3 minuses, 6. So that's -5. Okay, and then over here, that's just going to be 5. So that's minus 5j. And then this is minus 10k. Okay, so anytime I do the cross product, I am going to verify if it is actually correct by taking the dot product of the resulting vector. So this is the cross product, let's call it W. And I want to check whether that's correct. So I'm going to do the dot product with 5, 1, -3 and see if that's going to be 0. If that's the case, that is right, because the cross product is always perpendicular to each of the original vectors. So this would be -25. This is going to be plus -5 and then plus 30. So because this is 0, that check is correct. Now I have to do exact same thing. So -5, -5, -10. I am going to also dot that with the second vector and see if that is 0. So that gives me 0, then plus 10, and then minus 10, and that's also 0, so check. So I know that my cross product vector, this right here, this is correct. My next step is to find its magnitude, and that will give me the area of this parallelogram that I drew. So to find the magnitude, we take the square root and we square each component. Now the negatives do not ever put because there is no point because they will disappear when you square numbers. So this would be 5 squared plus 5 squared plus 10 squared. So this is 25, 25, 50, another 100. So this would be 150 for the area. Okay, but you could ask me, why did you find the area of this parallelogram? How is that going to relate to the distance from the point to this line? Well, think of this. Think of drawing a perpendicular line or line segment that has a 90-degree angle with the line. And that distance, if you call it d, that's the distance from the point to the line. Because what is the shortest distance from a point to a line? Draw a perpendicular and that d will give you the distance, okay? Now, we also know that area of a parallelogram is base times height. The base is the length of vector v. So this would be magnitude of v multiplied by the height, but the height is d. So all I have to do is find magnitude of v at this point. So let's see if we can do that. So let's remember what was vector v. So we found it, and it was 5, 1, -3. So this would be 5 squared plus 1 squared plus 3 squared. So that becomes 25 plus 1, 26, and 9. So I think that would be 35. So magnitude of v is square root of 35. So now what we get? We get 150 equal to square root of 35 multiplied what we need to know. So dividing both sides by square root of 35, which I don't think, I mean, maybe it can be simplified, but I think since this cancels here, this sort of answer is fine. So let's see if we can enter that and see if we get this correct. So we want square root of 150. And then we want to divide that by square root of 35. All right.